Okay, hello, hello. Can everyone hear me? Yeah? Oh, lovely. Okay. Okay, so thank you very much for that lovely announcement. I'm glad to see you all here. This is my first time at PopCon, or just this event in general, ever. So I'm just totally blown away right now. Do we have any other first-time PopConners in the audience? Yeah? Okay. I'm just totally blown away by like all the costumes and stuff. Like I can't believe it. Anyways, welcome to the panel. For those just rolling in, and anyone else, feel free to join anytime if you'd like as well. But for those just joining us, this is my panel. It's called Jurassic World Rebirth, Meet the Extinct Cast. Just as a disclaimer, I am in no way affiliated with Universal Studios or any of the people making those movies. I am just a person. I'm a paleontology student at the University of Saskatchewan, and today it is my pleasure to host this little panel with you and hopefully teach you a little bit about the fossils and the real science that goes into the making of these films, how the things you see on the screen differ from reality, and the ways in which they are the same. So what I'm going to do is I'm basically just going to do like a faux Meet the Cast panel, as the title says. But this isn't going to be any Meet the Cast panel like you've ever seen, because there aren't any human beings here aside from myself. Aside from me, it is all fossils. Some real, some replicas, but some genuine ones as well, as I said. And I'm going to walk you through some of the main creatures that you see popping up in the Jurassic Park, Jurassic World movies. And yeah, just give you a little introduction to them. And then afterwards, I'm going to bring some of these specimens out into the audience so that you can see them up close for yourselves. Because I know I am kind of a bit of a ways away up on here. So first of all, I am a huge fan of the Jurassic Park movies. I love them with all my heart. I've seen, the original ones came out before I was born, because I'm 20 years old, but the Jurassic World ones, I've seen every single one in the theater since the first one, all the three main ones, and now we have this new spin-off one, Jurassic World Rebirth, coming out this July, so I'm really excited about it. And we have lots of classic dinosaurs returning. We have some new ones, and we have the ones that we know and love from the movies that came before. The first one I'm going to talk to you about is one of the classics, and probably the most famous one that you see in these movies, the most iconic one, the face of the franchise, really, and that is, of course, the T-Rex, or Tyrannosaurus Rex. This is a replica tooth of a Tyrannosaurus Rex. It's actually really just the crown of the tooth, or the part that goes up above the gums. If it were a full-length tooth, it would be about the length of a banana. And you see, this tooth at the base, it's very thick, it's very robust. That differs from some of its closer relatives, like this Tarbosaurus. You see, in comparison, this was one of T-Rex's closest relatives, and yet the tooth is very different. It's very thin, not at all like this Iron Maiden spike that the T-Rex has for teeth. Very thick, very robust, and that is because the T-Rex didn't quite eat like its close relatives. It didn't just go for the meat of its prey. It ate the whole thing, bones included. And actually, some scientists have found fossilized poop or coprolites from T-Rex, and they contain pulverized shards of bone. So this was less like a wolf and more like a hyena, or more like an African wild dog. It was eating everything it could get of its prey, meat, bones, and all. And that's just a replica. But in my other hand here, on the other side of the table, I have a real fossil Tyrannosaur tooth from Montana. And I'm going to bring this out to you in just a moment. Now this tooth is a lot smaller. It doesn't come from T-Rex proper, probably not. But again, one of those closer relatives, something a bit like the Albertosaurus, which has a replica tooth here, which is quite common here in Canada, in Alberta. And now the T-Rex in Jurassic Park, there's one way, a reliable way to stay safe from the T-Rex. And do we know how you do that? How do you keep yourself safe if you're in a Jurassic Park movie and there's a T-Rex nearby? Don't move, right? In the very first movie, there's that iconic scene, and Dr. Grant says to the kids, "Don't move. You can't see us if we don't move," right? And it's a pretty safe trick. A lot of characters escape with their lives from this trick. But really, the T-Rex of reality, the one that lived about 65 million years ago, it could most certainly see you, even if you weren't moving. And the actual only way to stay safe from a T-Rex in reality would have been to run as fast as you can. Because the adult T-Rex wasn't much of a runner, at least not compared to it when it was in its teen years or its closer relative, this other Tyrannosaur species. Not much of a runner at all. The fastest human runners could have easily beaten a T-Rex. If you're not an Olympic runner, that's a different story. But at least the fastest humans on Earth could totally beat a T-Rex in a race. The next dinosaur I'm going to talk about is another really iconic one from the Jurassic Park and Jurassic World movies, that being the Velociraptor. The Velociraptor's shown up for everyone, and it's coming back for Rebirth in a new iteration. I think they've put some feathers on it, actually, because of recent discoveries showing that many of the smaller meat-eating dinosaurs had feathers, even some that were as large or approaching the size of Tyrannosaurus rex. Now, the Velociraptor, they have that really iconic big claw on the outer toe of each foot, which they like to tap on the ground or rip to shreds the human characters with. This is the base of a fossil claw from either Alberta or Montana, or around that area. Unfortunately, the tip has been broken off at some point, but it is the base of a claw of a small meat-eating dinosaur, possibly much like the Velociraptor. And this could have come from either the hand or maybe the foot. But either way, what you see is the base of it, where it would have articulated and moved up and down in relation to the other bones of the foot or hand. Now, in Rebirth, they're on a mission to get DNA. They want to get the DNA from, they say in the trailer, the 3 biggest dinosaurs. One of these dinosaurs, I'll come back to that in a minute actually, but one of these 3 biggest dinosaurs that they're introducing in this new movie is the Titanosaurus. The Titanosaurus has a long neck, a long tail, a tiny head on the end of that long neck. It's one of those Brontosaurus type long neck dinosaurs, and it was real. It's not made up for the movie. The Titanosaur group of sauropod dinosaurs lived near the end of the time of dinosaurs, shortly before that big asteroid hit the Earth. And they did indeed grow to very, really huge sizes, the biggest land animals that ever walked the Earth that we know of. Now these Titanosaurs, as adults, of course, they were huge, but they all had to hatch from an egg round about the size of a grapefruit. So they would hatch out this grapefruit, hatch to a little tiny sparrow-sized baby, and eventually grow into an animal almost the length and size of a blue whale. Again, the largest land animal in history. And this right here is a piece of one of those eggshells. It comes from Argentina. These Titanosaurs, the biggest ones, lived in South America, and they would go to the same place year after year to lay their eggs as a herd. And they would dig a shallow little nest, put a few, maybe 8 eggs inside, and then walk away. That was the end of that for them. And that's not because they didn't care about their young. It was part of their strategy. They would lay, between the whole herd, many hundreds and millions of these eggs. And they would all hatch. Many of them would be eaten by carnivores, like with sea turtles today. But they would lay so many eggs in the hopes that a few of them would grow to full size and go on to lay eggs of their own. And so they would go to these egg fields, which is where this shard of egg came from. So what I'm going to do now is I'm going to bring this piece of eggshell, the small dinosaur, the raptor claw, and the Tyrannosaur tooth around to you in the audience. I'm going to come back here, and then I'm going to introduce the next little group of fossils that I have to show you. Hey, thank you very much for bearing with me so I can show all of you that stuff. I did get a message from one of our audience members. Apparently, I didn't get quite hear it at all, but there is someone else in the audience who later in the presentation might like to come up on stage or just to me. He's going to come up on stage. Okay, there's another person who has some his own stuff to show, so I'm very much looking forward to that. Yeah, thank you, Paul, for taking a good look at those dinosaur fossils. Anybody who want to take photos, you absolutely can with any of the things I'm going to show today. You have full permission. Yeah, just feel free to do it. I mentioned this to a few of you when I was bringing them up close, but some of you may have noticed that the Tyrannosaur tooth has little tiny indentations in it. Little tiny serrations, and those are serrations, like how a steak knife has, which made it really, really good for slicing through meat. And then I also pointed out that the piece of eggshell from the Titanosaur has little perforations and holes on the surface. It's not quite a smooth eggshell. That's because all eggs need, however big they are, they need tiny holes that go through the surface of the shell to let in air so that the embryo can breathe. Now with a chicken egg, these are so small you can't even see them. But of course, with a grapefruit-sized egg like this came from, those indentations and holes are way more visible. And that's actually why the biggest egg of all time are laid by flightless birds like the ostrich and the extinct elephant bird. only grow up to about this in height. And that's super big for an egg, but the reason why they can't grow bigger than that is because if they did, those holes, which the embryo needs to survive, would either not be able to exist, and so it would suffocate, or it would compromise the integrity of the shell, and it would crumple. Now the next thing I have to show you are some other dinosaur fossils. Another iconic Jurassic Park dinosaur is the Triceratops. Has been a kind of background cameo character for the past few movies, but of course in the first one, it had that super iconic moment where it was sick and all the characters got out of the van to care for it. And this is a piece of bone from a Triceratops, again from Montana. It's difficult to say where exactly the body this came from, but it does have grooves on the surface, little rivers almost. And those may have been blood vessels. And if they were, that could mean that this bone came from the big frill on the back of its head, because that bone needed lots of blood vessels running around it to keep it fed with blood, and also maybe to make it perhaps change colors and look brightly colored during the mating season. So I'll leave this bone right up here. I won't bring this out to show you, but near the end of the presentation, if anyone would like to come up and look at this or any of the other things I'm going to show later, that is totally okay. I'd love it. Now the next thing I have, oh, thank you. Oh my gosh, look at that. Okay. Let's just do this right away. Thank you very much. Oh! Oh, thank you so much. Oh, what's your name? Mark. Thank you, Mark. Mark has brought in some incredible specimens. And are you just here as a guest of the con or whatever, or are you selling something? You just happen to be here. You're just here by chance. How marvelous. Okay, now I know exactly what these things are. This first is, may I touch it? Yeah? Okay, I'll be very delicate. This is a skull of a Titanosaurus. The Titanosaurus was one of the early ancestors of the Triceratops. It was very small. Well, I mean, the skull is pretty big, but the dinosaur itself was only about the size of a big dog. And it walked on 2 legs, maybe sometimes 4, but it was a very, very small dinosaur. No horns, no big frill, but over the many millions of years, these species adapted and grew and diversified into huge forms like the Triceratops. And now the second thing that Mark very generously brought for us is a huge ammonite. Now this ammonite is coated, I'd say head to toe, but it doesn't really have toes or a head. It's completely covered in a crystal, a kind of gemstone. This gemstone is called ammolite. It's very popular, mined in many places, particularly in northern Alberta. You can see it's shiny, it's iridescent, it's like a rainbow. And that's, it grows somehow during the fossilization process on these ammonite shells. Ammonite shells being, ammonites being a type of aquatic cephalopod or squid-like, octopus-like animal, which lived side by side with the dinosaurs and went extinct with them. It would have had tentacles and a kind of squid octopus body coming out the big end of that coiled up shell. So anyways, thank you very much to Mark for that. That's just incredible. My goodness. So yeah, this is the skull of a Titanosaurus and this big ammonite shell. And just to give you an idea of kind of the diversity of the ammonite group, I actually have my own ammonite right here, which is a much smaller species, and I'll show you it to compare with this huge one to show how biodiverse they really were. Here he is. Look at it. Look how small this one's and how big that one is. So they came in all different shapes and sizes, and not just this coiled form, they also came in paperclip shapes, which bent around in kind of unusual ways. They came in balls of yarn type of shape, straight shells. So yeah, anyways, thank you very much. That was incredible. Now I have another creature from the new Jurassic World movie to show you. Now, I mentioned earlier that in this new movie, the mission is to get the DNA of, they say, the 3 biggest dinosaurs. But that's actually not quite the case, because they're going after the Titanosaur, the sauropod, which is a real dinosaur, but then they're also getting the DNA of the Quetzalcoatlus, which is a flying pterosaur, a very big one, and the Mosasaur, a swimming reptile with many, many sharp teeth, which we've seen in the past couple of movies, actually. But neither of these creatures were actually dinosaurs. The pterosaurs belonged to a kind of sibling group of reptiles that were close to the dinosaurs but did not belong in that group, whereas the mosasaurs evolved from essentially monitor lizards or Komodo dragon type animals. So again, completely different group. But the mosasaurs grew, again, in all different shapes and sizes, from small puppy dog sized ones all the way up to the 50-foot in length type specimens which produce teeth like these sharp meat-eating teeth. They would have fed on fishes, on ammonites probably, on other reptiles, other mosasaurs, other fishes, and if a dinosaur washed out to sea, you can bet they would have fed on that too. So this is a tooth from a mosasaur. Comes from Morocco, Africa, and the mosasaur that produced this tooth was probably about the length of a school bus. Now the next thing that's super iconic about the Jurassic Park movies is the way they bring back these dinosaurs. How do they bring back the dinosaurs? Okay, the amber, the mosquitoes in the amber, right? So as the cartoon character, the Mr. DNA, explains so eloquently and so well in the first movie, we all remember what he says. He says, back in the age of dinosaurs, there were mosquitoes, and they fed on the blood of animals, even dinosaurs. And sometimes, after feeding on the dinosaur, he'd land on the branch of a tree and get caught in the sap. And that is absolutely true. That is one thing that you can trust the Jurassic Park movies to deliver accurate, well, semi-accurate information to you about. Amber is real, and this is a piece of it right here. And just as Mr. DNA says, it is hardened to solidified tree sap. And tree sap is very, very sticky. And it sure did catch mosquitoes, it caught insects, spiders, ants, even bigger things if the piece of sap was big enough. Things like birds, lizards, even small dinosaurs have been found entombed in this amber in smaller pieces. They found the tail of a dinosaur inside the amber. And now the very, very special thing about amber, and it contains leaves and plant parts too, and this piece I have right here has a little leaf in it. And the very special thing about amber is that the fossils that you find in this, the leaves, the insects, the little animals, are not replaced by minerals and rocks like these others that I've shown you. All of these that you've seen up till now have been petrified or solidified or permineralized, which means that they got buried at some point, and then over a long, long period of time, maybe hundreds of years, maybe millions of years, minerals and rocks filled in the empty spaces. Maybe the bone got buried, the rock hardened around the bone, then the bone rotted away, leaving an empty space, and another mineral came along and filled in that. Or maybe it was cell-by-cell replication, like these bones or these teeth. But no matter what happened, they were replaced. There is essentially nothing left of the original animal in all these fossils. They're more like a cast that the earth makes all by itself. However, with amber, that's not the case at all. Inside the amber, you have precisely the exact same animal that once lived many, many millions of years ago, 65 million years ago even, or older. And when you look at these animals, you are staring face to face, eye to eye, or eye to leaf in this case, with a living thing that lived millions and millions of years ago and is preserved exactly as is for you to look at. And I think that's really cool. Unfortunately, those mosquitoes, they do contain some kind of trace of blood, but it is not at all enough to reconstruct a full DNA strand, as they say, and bring back a dinosaur. That's unfortunately one area where they do take some Hollywood liberties and exaggerate the truth a little bit. But there's tons of interesting science that can still be done with this amber, even if it's not bringing back a T-Rex so that it can bust out and chase people around. There's still tons of interesting things to do. So what I'm going to do now is I'm going to bring around this amber piece and the mosasaur tooth that I was talking about earlier, and if I can fit it in my hand, maybe the Triceratops bone as well. And I'll bring these around to show you all. Thank you again for bearing with me. I hope you all got a good look. So, yes, unfortunately, as of right now, and probably forever, it's impossible to bring back a dinosaur from congealed blood inside a mosquito, inside the amber. Even though the thing is preserved as is, cell by cell, there's still a tiny bit of degradation. And unfortunately, DNA is just so fragile and so delicate, even frozen, it's very hard to survive and preserve it intact. But there are other things going on involving bringing back extinct animals, right? Just recently we had that company, Colossal Biosciences, which brought back the dire wolf. And the way they did this is by taking the genetic code, or DNA code, of the gray wolf. They had also examined the DNA from dire wolf fossils, dire wolf being this ferocious Ice Age relative of the wolf, which lived in the Ice Age period. And they compared the code of the dire wolf's DNA to figure out what kind of physical features and attributes it may have had in addition to the fossils. And then they altered the gray wolf DNA using CRISPR, using DNA editing software to alter the gray wolf's DNA, to make it look more like a dire wolf, without of course hurting the wolf. But they went as far as they could to bring back these features.
It's time for some more trivia, so when I say trivia, you say time. Trivia! Trivia! Okay, here's the question. For a prize from our good friends over at Dragon's Den, what is the shape associated with the highest rank amongst cards in Squid Games? First one with the answer in the information booth was a prize from Dragon's Den.
Okay, you remember that. So, I would try talking over, but I tried talking over yesterday, it just didn't work. So they edited this DNA to make it look, the gray wolf look like a dire wolf. And people are debating what this means, right? Can we actually call this a dire wolf? What does it mean? And the truth is probably somewhere in the middle. They've brought back many of the features of this extinct dire wolf, but the animal at its core is still a gray wolf. But it is still very, very cool science. And it's a stepping stone on the way to potentially doing more in the future. Right now, we have the most incredible ability to examine ancient DNA, to examine these fossil species, and there are many groups and individuals trying to do science with that, trying to push that forward.
Number one is square. One more time. I say trivia, you say time. Trivia! Trivia! Thank you.
And so somebody asked me yesterday, actually, when I was doing this panel, should we bring back dinosaurs if we could? Obviously, I'm a little bit biased, and I said yes, unreservedly. But it is a bit of a frightening concept, because if we bring back dinosaurs, where do they go? Where do they live? We can't release them into the wild, obviously. And so if we were to bring back dinosaurs using science, using genetic editing, they would probably be put in some kind of enclosed area, some kind of Jurassic Park, if you will. And so how would that look? How would that work? What would that look like? Who knows? But it's certainly all very, very exciting. So that sort of brings the end of the dinosaur fossils that I have to show you. Again, of course, we have this Triceratops one, we have all this stuff, this Titanosaurus skull, which is very, very cool. I'm just spotlighting that right now. But we've got all this stuff. So right now, I think I'm gonna try to take a couple questions, because by this time yesterday, a couple people did have some questions that they wanted to ask. And then after I do the little question taking period, I'll transition into the sort of final part of the panel where I introduce some other fossils of creatures that lived with the dinosaurs, yet were not dinosaurs, as well as some real fossils from Saskatoon and Saskatchewan that belong to a bit of a later time period, a bit closer to our modern area than the time of dinosaurs. So yes, anyone who would like to ask a question, there's a microphone that they set up for me very generously in the middle of the room. And please do go up and say your piece. Thank you.
Well, so given like the dire wolf kind of process spread direction, do you think it'd be possible to do the same and say something like woolly mammoth? I know we have like permafrost preserved soft tissue samples of those animals, but would their DNA still be like too damaged in that circumstance?
Okay, so the question was, that there was that whole dire wolf thing, right? Could we do something similar? Could Colossal Biosciences or a similar company do something similar for the woolly mammoth? And they would say yes, because they are trying to do that right now. What they are likely going to do, if they wind up doing it, which I don't know if they will, if they wind up doing it, what they will likely do is they will do something similar for the woolly mammoth. They will take its closest living relative, which is of course the African elephant, the only animal around today that's huge and has a big trunk, you know, the family resemblance is pretty clear. They'll take the African elephant or the Asian elephant, and they'll alter its genes to express maybe long fur, longer tusks, curvier tusks, smaller ears, a shorter tail, things like that. The thing is, they still have quite a bit of difficulty with just simply making an extinct embryo and then putting it inside some other animal and hoping it works out. That was what was being discussed for a long time. I remember when I was a kid that there was a lot of talk of that. But I think they're simply, it's still too far a leap to accomplish right now. And so if they do it soon, it will likely be through that method. If they do it further in the future, who knows? They may be able to achieve that true replication where it is an actual woolly mammoth embryo. But again, that science is really, really far away at the moment, unfortunately. So yeah.
Thank you.
Okay, anyone else with questions? The microphone is still there. And if I'll give like a 10 seconds for questions. And then if there's not any, I'll just keep talking. Okay, thank you very much. What I will do now is I'll transition, again, as I said, into this last portion where I show you some Saskatchewan fossils. So we were talking earlier about the ammonite. We've of course got the huge impressive one on that side of the table, and we got the littler one I showed you earlier. Now again, these ammonites were like a squid. They were like an octopus. They were cephalopods, so they had tentacles. But they lived in these hardened shells. And as I said, these shells came in many shapes and sizes, including straight ones that were just like a long ice cream cone. And these white fragments that you see in this reddish rock right here, these rocks come from a place called Elbow in Saskatchewan. It's on the shores of Lake Diefenbaker. And again, these white pieces, I almost dropped it, these white pieces are shards and pieces of the shell of one of those straight-shelled ammonites called a baculite. They could go to probably be along about this length from the microphone hand to the other hand, and potentially a little bit longer. This right here, you see it's white on both sides. This is a kind of section, a kind of cut-out cinnamon roll section of that long cone-shaped shell. It's been squished a little bit by the pressures of geology. You can see it would have been more rounder in life, but this is a whole section of that big shell. I showed you the ammonites. We have the ammonites, of course, and those glittering, iridescent, beautiful ones. This one comes from Alberta, and this one, the smaller one, comes from Madagascar, actually. And you'll see if you look closely, it too has that shimmering shininess to it. I have a clam as well. Now during the later time of the age of dinosaurs, from about 75, 80 million years to 65 million years ago, approximately, both Alberta and Saskatchewan, we were under a shallow ocean, an inland sea called the Western Interior Seaway or the Bearpaw Seaway. And so here in Alberta, in Saskatchewan as well as Alberta, and BC a bit too, we get fossils of sea creatures. So you've seen the ammonites, you've seen the baculites. This is a clam. Looks like an ordinary clam, really. But fully grown, members of this clam genus could grow in length longer than a human is tall, the average adult human. So pretty much, unless you're super, super tall, you could lie on your back inside the shell of this clam if it were fully grown. It's called Inoceremus clam. And the last thing, I have to reach a bit. Where is it? Here it is. In this bag. Now these things, they look like a bullet. They look sharp, maybe a bit like a pointy tooth. But they're not bullets, and they're not teeth either. In ancient times, don't ask me about history, I don't know about human history, but in ancient times, people thought, they called these thunderstones, in Victorian England, I think. And the belief was that when lightning strikes, it's because of these pointy rocks. They formed in the atmosphere, and when you would shoot down and crash to Earth, leaving a trail of lightning, and if you were to find these on the ground, you would know lightning struck there. It's a lovely story, but unfortunately it's not true. These are styluses, or support structures, that used to exist inside the body of an animal called the belemnite. And the belemnite looked almost exactly like a squid. They could be smaller, they could be larger, squid-like animal. And these things, these bullet-shaped things, were inside the body, and they helped to support the body of the squid, keep it stable. Or belemnite, excuse me. Modern day squids have something similar. It's a bit more flimsy, so it doesn't fossilize as easily, but it's still there. And this structure is kind of like plastic, and it's shaped a bit like a bullet too. It's shaped like these. And so people who prepare seafood, when they're preparing the squid to cook, they have to remove that support structure. And now if you can imagine a squid, it has that pointed body with the fins on either side and then the tentacles coming out. So the person preparing that squid, he has to take out that support structure from the body. And that's why calamari comes in rings. It comes in tentacles and it comes in rings. Because of course the meaty body of the squid becomes a ring shape when you remove that inner supporting structure. So this is some belemnites. And so these are all sea creatures that lived side by side with the dinosaurs in the oceans of the world, including right here many millions of years ago. Now we have tons of fossils right here in Saskatoon as well. They're not quite as old because the deposits that would contain dinosaurs, that would contain all these super old extinct animals, are buried beneath almost 100, in some places, 100 meters of dirt and muck and mud and sediment and sand. That was all deposited by glaciers in the Ice Age or Quaternary period, the Pleistocene epoch. And at this time, again, starting about 2 million years before present day, things got colder all over the world and snow accumulated and formed these big ice fields, these big glaciers, and tore up the landscape and dumped, essentially, all this dirt and mud all across some places of North America, including Saskatoon. Then at the end of it, when things were getting warmer, about 12,000 years ago, all this ice and snow was melting. It eventually drained off into the oceans and into Hudson's Bay, but before it did, it formed really, really big lakes, some cases as big as Lake Erie, on the surface of North America. And here we were no different. And these actually helped us to give us those really fertile, really rich soils, which are so good for farming today, in here as well as some parts of the States. So, these lakes, which existed again about 12,000, 10,000 years ago, they were huge. And there were many aquatic animals living in these lakes, and there were plants growing on the shore, animals living on the shore. And sometimes these things would fall into the water or die off, float to the bottom of the lake, and get buried by layer after layer after layer of silt and mud. And so I have some of those type of fossils here today. The first one I'm going to show you, I'm going to bring these around. The first one I'm going to show is a small plant, maybe a grass stem, maybe a little leaf, maybe something from a little bush, that fell into the water or was maybe an aquatic plant and then got buried and preserved as a fossil. The next thing is a tiny burrow that was made by a bug or a worm, earthworm, or aquatic worm, or a beetle larva, or something like that, that was tunneling through the mud to get from one place to the other. And then the final thing I'll show you is a fossil limb bone, or the femur of the leg of a squirrel, some type of rodent that lived in the Ice Age 12,000 years ago. And these are all from Saskatoon, city of Saskatoon. So I'll bring those around to show you just now. Okay, now with that, that's the last time I'll be running around in the stands between you guys to show you something. That sort of brings in the end of the presentation. One thing I forgot to mention is that when I showed you the squirrel bone, you saw that it's in many little pieces. That's because young animals, their bones haven't really fused together yet. You see this with babies too. We have that soft spot in the middle of a baby's head. So this squirrel is probably a young one, maybe not a baby, but at least a juvenile or teenage, adolescent one. Because the parts of the femur, again, they hadn't fused together. They were buried together, but as soon as I took the bone out from the sediment it was buried in, it came apart. So those are all the fossils I have to show you myself. Again, I think I'll leave it again up to questions. The microphone's still there. It should still be on. But otherwise, I release you. You're free again to go about your daily life. You don't have to listen to me anymore. But if you'd like, you can absolutely come up on stage and inspect your fossils. Or if you gave me some fossils, you're also welcome to come and retrieve them whenever you'd like. But thank you all very much. I hope you have an excellent rest of your day here at PopConYXE. And thank you all once again.